go hiking?
I do want to go hiking. Yes, absolutely. My brother got our family's car out of the garage that it's kept in, so we've got it near my house in Brooklyn now. So that's something I definitely want to do. But I've heard that a lot of the hiking trails, like close to New York City, are pretty crowded.
The ones you know about.
Oh,
right. Hey, we're live.
Oh,
yeah. We're talking about hiking near New York City, but now we're going to talk about DSP. Or just
not really
a bunch of DSP engineers talking about stuff, right?
Yeah.
We're live, right? Yeah. I'm Russ from Eventide. I'm the self-appointed, boss-approved director of signal processing, DSP. It's kind of our joke. And I asked a bunch of friends to get together. These are people that I know from either for a long time from Eventide working or graduate school, or people I've met in the DAFX community. That's Digital Audio Effects. It's a conference that happens every year in Europe. So this is a collection of fellow engineers and educators and researchers. And we're drinking, and we're going to try to talk about DSP. So I'm drinking some Lafroig, and I'm mixing it with New York City tap water.
Is there a noticeable taste difference when you mix it with other tap water? Like, is it the same thing for the bagels?
I think so. Yeah, it would have to be. Yeah, without a doubt. New York City water has like special little shrimps in it, I've heard.
The shrimps are tasty.
Yeah, they're pretty good.
That's what makes the bagels good.
Yep.
So monkeys.
Yeah, like sea monkeys. Yeah, like little. So I'll kind of go around my my Brady Bunch grid here and ask people to introduce themselves. So I'm just gonna kind of follow the grid. I'm in the middle, so I'm gonna go to my left. No one can really see that, but
no.
Nope. I'm gonna go to Dan.
Hey, I'm Dan. I'm here representing Bears, but also Newfangled Audio. I'm drinking Talisker.
Oh, nice. A lot of scotch here.
Distiller's edition. I bought that bottle when I graduated grad school. And I opened it when we shipped Elevate.
Yeah.
Oh, wow. And now how fast have you gone through it?
It's been 2.5 years. I'm about halfway through. So
that's a lot of restraint.
Special occasions like this.
Thanks, Dan.
Who's next?
You are.
I am. All right. Hi, everyone. I'm Fabian. I'm a DSP developer at Native Instruments in Berlin. And I am drinking Carl Isla, which happens to be my favorite scotch. And I bought this one last year when I visited Stefan at the University of Edinburgh. I was teaching there for a couple of days, and I picked this one up on the way back. That was around a year ago, and it's almost gone. It would be gone, but I forgot I had it for a while, so I stopped drinking it. But highly recommended.
Stefan.
Hey, yeah, up here in Edinburgh, in Scotland. I'm drinking some kind of suspiciously red IPA. I forget the name of it, but it tastes all right. Yeah, I'm at the University of Edinburgh up here. So,
what do you do at the University of Edinburgh?
Oh yeah, I'm in the music department. So I'm in something called the Acoustics and Audio group, and we just do a lot of synthesis, audio effects, that kind of stuff. Our stuff basically. So DAFX type stuff.
DAFX big. You do. I think you might have the biggest math of everyone here. Maybe you.
I don't know, man. I don't know what that. I'm not going to show it to anybody, but I mean.
Say it.
No.
Let's go to Kurt.
Okay, next.
Well, I just want to say the biggest math is a great metric. Anyway, I'm Kurt Werner. I'm a research engineer at iZotope, and I've been drinking cold coffee, but I realized there was one beer left in the fridge from Freebird. It's the Freebird Ale. Keep saying Freebird. Freebird Ale from Lord Hobo up the street.
I would definitely drink a Freebird Ale.
Yeah.
Yes, for sure. How do you think that would taste?
Free? You get what you pay for?
Yeah.
Not great, not bad.
Yeah,
Not great, not bad. So
better than you'd expect for free.
For a free beer.
Woody.
Hello, I'm Woody. I also work at Eventide doing DSP stuff. And I am drinking a little aperitivo, which is Prosecco, some kind of aperitivo like Aperol or Campari soda. And it's very tasty, although a little cold. I like it when it's much sunnier and warm outside, and right now it's cold and gray and rainy. So,
It's a good day to go on that hike though, because there's less people out.
yes, would be a great day to do any activity in New York City. Yeah, not like this weekend. This weekend was very crowded. Yeah.
Chris, me and Chris knew each other from graduate school.
Yeah, so we've known each other for like 12 years, 12 or
Yeah.
13 years.
Where was that?
The University of Miami. So we overlapped by 1 year there. And yeah, my name is Chris Santoro. I do R&D at Soundtoys. And I am drinking some overproof rum, which is also flammable. And yeah, that's it.
Let's see where this goes. Light it up, right?
I had to add some water to it, definitely.
Yeah, that's what I've been doing.
No longer flammable.
One of the best things about drinking scotch is at the Daffix at Edinburgh was when you guys treated us to the scotch tasting, is how to add water to scotch
That was great, yeah.
Oh, that was phenomenal.
and how never to use ice because that's uncivilized.
I remember being there, but I don't remember much from that night.
Yeah. Oh man, considering how much you guys drank, man, that was impressive, So,
We're good at that, right? I guess.
well, yeah, I mean,
Dave.
Yeah, right. I'm Dave. I'm a researcher at University of Plymouth, working on a project building adaptive radio technology for people with dementia. It's the project I'm on at the moment. And I'm drinking Brewdog Punk IPA at the moment, although I've been inspired, so I might move on to one of my Lefroy pretty soon, because I'm getting quite jealous.
Sorry to interrupt, Dave. How long have you been at Plymouth? I didn't know.
I moved down in November, so I've been here for almost 6 months, and it feels like half of that's been in this one flat. So.
Right, congrats, I didn't know.
Yeah. Before I was up in London, and I'm quite grateful that I ended up in lockdown in a smaller city a little bit further out, rather than being in the centre of London, because that would have been bad.
Yeah. And last but not least, Julian.
Right, yeah. Hi, everyone. I'm Julian. I also work at Native Instruments, where I do DSP and machine learning stuff. And tonight I'm drinking a very fine bottle of Alapus Mezcal, which was gifted to me by Fabian on my wedding day.
Can we swap? I would normally drink mezcal, but I ran out, and the shop where I get it from has been closed for 2 months now.
I ran out of scotch, so it's kind of an ironic reversal.
I'm gonna cycle to you over the weekend, and we can switch bottles.
I like this just as much, though.
Yeah, this is great.
So since we've all been in lockdown, are you guys are you finding that you're working more? Are you making more music if you're into that, or how's it? What's inspiring you? What's keeping you going?
I think it's amazing, personally.
You have a nice view.
Good view, yeah.
Your office has your home office has a better view than the real office.
But I think cutting out like the commute from your life gives you so much extra time.
Yeah.
Like you can replace that with music or reading or whatever. Like it just feels a bit more, I don't know.
How long was you prior to this?
Like an hour, basically, door to door.
Oh wow, that's a long one.
Yeah. My own stupid fault.
Well, yeah, okay. I was already working from home like 4 days a week, so I 100% agree with you that it's, as long as you're set up to work at home, it's definitely nicer. But now my 2-year-old's at home too, so that takes a lot of time back.
You can't hand off some of your work to him?
That's true. I hadn't considered that.
See how he does. Maybe he's got a natural talent.
Or just some some new ideas in the world of DSP.
Yeah.
Are we out of ideas here? Do we need new ideas? Do we
Well,
need
you never know. Yeah, have you considered smashing an SVF with a block? I mean, that might give you some new ideas.
That could definitely work.
My son routinely builds computers out of magnetiles and works on them. I don't know where he's getting or what he's doing.
Magnetiles almost cost as much as computers.
That's right. Yeah, they're expensive.
My son calls the H9000 his computer, and he'll come into my office and start poking it and say, I'm computering with daddy.
Computering with daddy.
Pretty adorable.
My son calls the H9000 that giant guitar, or no, that giant pedal. That's what he called it. That giant pedal. Yeah, the lack of commute's great. I find myself, I'm answering my own question. Whatever. There's a leading question I want to talk about myself.
I would be curious to hear from Stefan because he's in a different position to us.
Yeah.
Teaching, how's teaching going?
Yeah.
Well, I mean, there isn't any, what's hard to say? It's just done, So, what do we do at the university? We kind of, lockdown came quite late here, right? So we were one of the last countries to go in. And by the time it came in, the semester was almost over. So there was not much to do, and it's done for the summer. So we're it hasn't really had a huge impact. Well, I don't know, some of the, it's sad because the fun part of the year, the master's supervisions are going to get all messed up because, people can't go out and, I don't know, build stuff or go and, measure impulse responses and stuff like that. So that's gone, but otherwise it's, it's okay. It's been pretty smooth actually.
So students are working on the final projects right now
yeah, we just got started. Yeah.
All right.
So yeah, lots of VA by the way this year. So there'll be some new VA people coming through. I think I already put you in touch with a few, right? So did I? No, maybe not. I will soon. It's coming.
Yeah. Any help?
How many guys on this call were students of Stefan's at some point in time?
Just Julian and Fabian, I think.
Okay.
Yeah, I mean,
I thought maybe Dave was, but maybe that's just because you're Scottish. I don't know.
Well, I went to Edinburgh, but I was in the computing department rather than the musical acoustics.
People, can you find one?
Got it.
Stefan, do you have to do any virtual lectures or anything like that, or is it just helping people with this?
Yeah, it's just a lot of one-to-one supervisions right now. So yeah, loads of that stuff. Which I don't know how you guys do it, but it's getting old actually doing that kind of thing. I mean, do you guys have to do that for work meetings then? I guess, right? I mean,
the video conferences.
Yeah. You checking in with your bosses every day and stuff, or? No, not even.
Yeah, I mean, Russ is technically my boss. So
am I? Yeah, I guess I am technically your boss.
Yeah. My boss.
All right.
Yeah.
I check up on Woody every once in a while.
Yeah.
Generally.
But what about it native? It's where it's. I mean, they're probably more uptight about that kind of thing there. No. Or
no, definitely not.
Are they not? Okay. Just it's a big company. I figured they might have more structure.
Quite the opposite. I don't think. I mean, me and Fabian, we sit in a Google Meet with our other colleague Boris all day and talk to each other, and then we talk to other people once a week, basically.
Oh, awesome!
Well, we have a Google Hangout running all day, basically from during work hours, and we're each working on our stuff or collaborating on a project, but we're always we can just talk, and the other people will hear. Yeah, we have this full-time Hangout on. It's worked really well, I think.
But that's not something that's been imposed on us. That's just kind of what we arrived at as a way we liked to approach it.
Do you guys work in a bullpen at Native normally? In this sort of open office, or are you?
Yeah, sure. We've got like desks next to each other.
Okay,
Well, we sure enough there's 8 of us in one room.
sure.
Is that
Yeah.
all? Is that all DSP guys, or is it? Or are you guys mainly the out of this giant native? I just imagine it's like just like 2 or 3 of you doing like the lion's share of the work. Signal
4.
processing.
I would say 4 right
4.
now. What do you say, Julian?
I mean, yeah, it's literally 4, right?
Yeah. So I've been reading a lot of the book, the famous The Art of VA Filter Design. What was his name?
Buddy,
Oh, right, Vadim. I wasn't actually including him in that 4. He's not doing DSP at the moment.
Okay.
He's working on Contact
Okay.
as an application developer.
Yep.
That's his thing at the moment. He wears many hats.
It was an interesting. It's a kind of enigmatic book, at least maybe for an electrical engineer like me. Like it's like I have to read it a chapter like 8 times, but it's really insightful, but I can't I just don't get it right away. It's really does anyone else have that experience with this book?
I mean, the thing with Vadim is he's a super clever guy and he likes to work things out from scratch on his own. So often he comes up with his own notations for stuff just because that's the way he's worked it out. So I think it's kind of a little bit difficult to get into from the outside. But there's usually a connection there. You just have to work out what the translation is and then you're all good.
Yeah, it's like a little bit idiosyncratic, and he tries to kind of avoid all the normal textbook things that you can find.
I don't think that's intentional though. That's just like.
No, he makes some sort of statement about it in the introduction, I think.
It's an intentionally idiosyncratic statement.
I don't mean that as a bad thing. I just mean that he kind of, at least reading between the lines in the introduction, it seems like he's trying to just target things that aren't well represented in other books.
Is that book has it influenced the way you guys work or code at Native?
Not really.
For Reactor, it does, right?
I mean, yeah, it's useful. Yeah, I mean, there's a lot of great stuff that was made for Reactor using that approach, and then we made this framework that lets you do filters in that style very easily in Reactor. But I'd say for our normal stuff, like C++ based stuff, it's mainly done by other people. So, and we've all got our own knowledge coming from other places, and that's not necessarily maybe the paradigm that we're most comfortable in.
Okay. Huh.
Yeah, I feel like the book, I've talked to Vadim about it, and the way that some of the filter methods are presented, they're coming from a graphical perspective. So it's how to design filters graphically and how to solve the implicit equations graphically without really having to do matrix inversions, for example, which in Reactor works perfectly because it's quite suited for that. But in C++, you can do the matrix inversion and maybe it'll be a bit more readable or straightforward to do.
So why would you not want to do a matrix inversion? Explain this to people who might be watching that are like, what now? What? They're asking us why we're talking about that movie.
No, but in the end, you end up doing the matrix inversion either way.
Yeah, but I'd say why would you not want to do it?
Well, I would say
directly.
Well, I would say you should want to do it. There's nothing wrong with wanting to do a matrix inversion, but I guess from a more traditional point of view, the matrix inversion can be seen as an expensive operation, right?
Like it costs a lot of dollars.
It's costs a lot of CPU dollars.
Yeah,
no, that's not CPU dollars. CPU cycles. So it can be slow. Let's say.
Like, do you mean that he wants to have like a kind of a flow graph representation of everything you can do, like a picture, a diagram or something, rather than a math, like equations or something?
Yeah,
sure, that's what I meant. But yeah.
Yeah. Okay.
Sorry, Julian, go on.
Well, Kurt would know a lot about
graphical
schematic processing, right?
Yeah, I don't know if I entirely understand Vadim's book. Like, it seems to me like he is doing the matrix inversion. I don't know if I understand it properly.
I think he is. Yeah, that's what I
mean. He just he starts with the this is how I understand it. Please, Julian or Fabian, correct me. But I think he starts with the signal flow graph in continuous time. Then he, what like an S-plane thing. So he has a bunch of integrators. Then he discretizes the integrators with the trapezoidal rule, usually implementing them with the transposed direct form 2 version of the integrator.
I'm just laughing about how amazing this is.
I don't know much about this, but
well, that's the part that makes sense. And then if you do that, the integrator has a delay-free path through it. So if your circuit had any feedback in it, you now have like these delay-free loops. So I think he then just resolves them with a matrix inverse. It's just you're not doing the matrix inverse at runtime. You're doing it to like transform that structure into another structure.
Well, you're kind of decomposing it into lots of just individual divisions.
Yeah.
Yeah.
You spread it out.
Yeah,
So-
it sort of never writes the matrix equation.
No, there's no matrix involved.
But it's equivalent.
Right.
So
Yeah.
a few years ago, this was pretty contentious on the emails listservs we all subscribed to. This idea of delay-free loops. I found it entertaining.
This is like the main DSP beef of the last.
This is
Yeah.
going great.
I
I
know.
like this.
This is kind of like the Great Schism, isn't it? Like
Boogeyman.
the boogeyman. Like,
I was gonna say,
and it's amazing that all these people from all these different companies and different academic institutions. I don't know, maybe not Dave, because you were researching different stuff. I don't know. Did you follow any of this, Dave?
Nope.
Nope, not at all. So, I don't mean to be intentionally excluding you. I just find this topic
No,
entertaining.
go for it. Go for it.
What's the rundown? What was the disagreement? Because I don't think I.
Yeah, I would like to hear somebody explain it in layman's terms, such that if
I
anyone
think
is
it
listening,
predates us.
Yeah,
Does it predate
it's been around like for a while, but like, isn't the main thing that people just have wildly different ways of explaining kind of the same thing? Like some people explain, I think the zero delay feedback thing, like it talks about like solving part of the circuit, the loop in some way, and then like putting in this extra input, and like it's a very like, I don't know, it's about like decomposing signals, but you can just see it as like solving the implicit part with the matrix inverse. And then I don't know.
there was wasn't there like a Moog filter implementation from like the mid or early 2000s where instead of actually solving the equation, someone just added an additional delay on the feedback?
Yeah, that was Julius and Tim Stilson. That was like one of the first VA papers.
Yeah.
Also
And
IP.
there's the Chamberlain SVF, which takes the just a circuit diagram of a state variable filter. So for anyone, if I'm just boring somebody, I see a comment from James. It's private, but relate this back to how it affects the real world use of sound. Right. All right. So let's dig. I'm gonna attempt to dig this back out. State variable filter gives you a different outputs with the same processing structure. If you can imagine a piece of analog gear where you can get a notch filter, a band pass filter, a low pass, and a high pass. And if you combine those things, you can get all kinds of filter shapes with any combination of those things. So a way to, doing this digitally is problematic, because if you look at the circuit diagram, if you were just to implement it directly digitally, like just looking at it graphically, you end up with this feedback loop. Anything based on an op amp, an electronic component that is an ideal amplifier, has to have feedback for stability reasons generally. Now, is that enough to say, right?
Yeah, op-amp circuits almost always have feedback.
Almost always, yeah.
Negative feedback.
Negative feedback, right?
Not the WASP filter. Was it the WASP filter?
Well, that's not an op-amp.
That's
No.
CMOS. That's a different beast.
That's like a weird
Yeah.
CMOS. It's a CMOS inverter used as an amplifier.
But it's
Yeah.
also an SVF.
And it only works because it has such poor bandwidth in the first place.
So the problem is, like, you can't have feedback in a digital system without an implicit delay, right? Because it's like you can only process things in one direction.
No,
Right.
that's not. You can solve them simultaneously. Like I think that's the whole. That's
Okay,
the,
in a naive,
totally
in
the
a
point where
naive,
everybody got stuck.
yeah, that's the point everyone
Yeah,
got
reason.
stuck. So I'm trying to describe to how this relates to everyone else out there who's a guitar player. Like they're like, well, no shit. How does this affect the way it sounds, right? So the original digital implementations were just sort of naively stuck a delay and said, good enough for rock and roll. And all the guitar players were like, sounds digital. That filter doesn't sound right, So
well, I guess if you're oversampled, it's probably, I don't know how bad that is then. Like if you're 8 times oversampled or something, right?
That's a brute force trick, right?
Yeah.
That's a good point, though. I mean,
yeah. So, hence, we've all been arguing about digital filters for the past 25 years.
Yeah.
I don't know. Maybe James can tell me if that made any sense whatsoever to anyone listening.
do the people, anyone who is watching this, I don't know if anyone is.
I can look at the
Probably don't
Facebook
know
comments.
James
Yeah, they probably changed the channel a long time ago.
James is the guy who's is behind this muted thing. I think
he's the showrunner, right?
Yeah, he's the showrunner. He's the Wizard of Oz.
Let me see if we have any comments whatsoever. It'd probably just be 0.
No, we've got lots of comments.
We do. Okay.
Yeah, we even have questions.
No, should we answer questions?
We should answer questions.
Wait, where is this stuff? Is this on Facebook?
It's on Facebook. Yeah.
Okay.
I'm amazed. Wow. We actually.
Oh, it looks like a lot of friends. There's the showrunner. That's the way to say it, right?
Now we're all looking ourselves up on Facebook.
Yeah, now we're wasting time.
Sorry, it started playing on me. I was getting really confused.
So while he's checking that out, I have a question for like Julian and Kurt and Fabian, like you guys that work for kind of larger companies, like what percentage of your work is like highly collaborative and what percentage of it is individual, and how has that been affected by working from home?
At iZotope, on the research team, we don't do a ton of like direct collaboration with people when we're working on stuff. I mean, some of our research is like directed by product, but like nominally we're supposed to do 50% self-directed research and 50% kind of research to support the product line that exists. So I don't think work from home has changed it all that much. And I mean, we also used Zoom for a long time. Like we already used it for nearly every meeting because we have a lot of remote people and people work from home 1 day a week. But I think the main thing that's changed is that like you don't get like the kind of random meetings with people like at the water cooler and stuff. At least that's what's changed on the research side of things. Like it's just kind of structured meetings, and you don't get these capricious things where you get to chat with someone about something and just kick the tires and share ideas like that. That's the main thing that's changed in a bad way.
For better and for worse, right? Because at the same time, like you don't get those capricious meetings like you said, but at the same time, no one can come like burst your thought bubble.
Yeah.
Get more like cave time.
Yeah, that's true.
It's funny. I think the more DSP kind of research intensive work, you're kind of in a cave already. And I don't really like working from home in general, just because like the DSP research stuff already feels like I'm in a cave, kind of, because you're looking at something so specific that it's kind of, then you have to start breaking it down for anyone you talk to just for like a general opinion or something. So working from home and doing that more like DSP research kind of stuff where you're in a cave has just amplified that fact for me sometimes. I think like I just feel even more in a cave, partly because I can't leave my house. So now it's starting to feel like a cave, but
yeah.
also in the sense of like the kind of work. And like Kurt said, I just kind of like the water cooler stuff is like a nice interruption for that, in my opinion. Like just to get out of your head cave a little bit.
Are you guys mostly working on just one thing at a time, like one project, or do you like switch up between a couple different projects?
I'm always doing a few things at once.
Yeah, I switch up between 2 or 3, usually like a varying scope. There will be like one small bite thing and one really big, like years long thing. So like you can get some thing, and then you can also, work on some long range stuff.
Sure.
That balance is really nice. I think like having something that's more longer term and then having something that's more immediate that you can kind of like switch back and forth between, I think is really helpful because it just like it resets your brain, because the short-term stuff is usually like a smaller problem that you know has an answer. And the long-term stuff is like usually you're trying to find an answer to something that you don't necessarily know has an answer yet or not. And so that kind of balance I think is really nice.
Going off of what you said about like being in a cave and what Julian said about having no commute, is one problem I have is when you're really zoomed in on some DSP math heavy stuff, and then you immediately like exit your office and you go like have dinner with your family or your significant other, and you feel like you can't really have a conversation with another human like in that, especially someone who's not like immersed in that. It's like, oh, how was your day? It's like, well, you know,
That's hard.
I was trying to invert a cope with matrix and blah blah blah, and they're like,
My wife knows a lot about this stuff now because I'll just dump, like, because sometimes too, that's the other thing about being in an office is you can go and talk to someone about it, and even if they're not giving you feedback, just saying it out loud and like synthesizing your thoughts will give you a lot of perspective on it. So I'll talk to my wife. I'll talk at her about it. I'll be like, oh, so I'm working on this. Blah, blah, blah. And I'll be like, oh, great talk. Thanks. I solved it.
Yeah, it's like that thing where you go to ask a question, like you're stuck on something and you go to ask someone a question about it. And in asking the question, you actually like, as you hear yourself asking the question, you kind of like answer it yourself. And you're like, oh, wait a minute. Yeah.
That happens to me a lot. Well, when at the office, I sit across from Julian, and when I'm stuck with something and I phrase a question, I usually say like, oh, never mind. When phrasing it, I just figure it out.
Yeah.
I know that feeling, Woody.
Yes. Oh yeah.
Thinking about your original question though, Chris, I guess we're maybe a little bit odd, because I would say that we're kind of working collaboratively like 100% of the time. I mean, people go off on little tangents on their own maybe, but yeah, I'd say like we're basically like talking the whole time, working through problems together. I mean, even like, I guess we're not doing heavy algebra together, although occasionally on the board, but like definitely pair programming a lot, stuff like this.
I would agree, yeah.
That seems to be what works for us. I didn't really think that might be unusual actually, but maybe it is.
I've never pair programmed. Do you guys do that now, even though you're not in the same room?
Oh yeah.
it's got to be better, I would think, when you both have your own screen than sitting next to
There's some really
it's actually really, yeah, it's super easy when you're remote. I mean, either you can share your screen over the video chat, or you use, well, we've been using Live Share for Visual Studio Code, I think, which means you can just edit code like it's a Google Doc or something. So you all have your own cursors. I mean, it works perfectly, basically.
Yeah.
We're getting several questions about from EEs here. What are some good ways to get better with DSP for audio? People graduating with electrical engineering degrees took several DSP courses, but haven't done much work outside of MATLAB. What's your suggestion for an EE student who wants to work in the audio industry as a DSP engineer? Should we tell them to go work in finance?
Masters with Stefan.
Yeah, I was gonna like sell my ass here. Like, come to the masters.
Yeah, go to Edinburgh, right?
I would go to Edinburgh.
Yeah.
Hey, no, I did EE. Yeah,
Maybe
I'm an EE graduate.
Just wait a year, like not this year, but
Not sure.
It's actually, that's an interesting question I get a lot. I try to do work with students sometimes, and they are almost always good programmers who are doing some schooling for like audio and that, but they haven't really done like DSP classes or signal and systems classes because they didn't do it in electrical engineering, or they're doing some amount of DSP and they want to know more about analog electronics because they didn't do a double E. And I honestly I don't know what to tell them, because the way I learned analog electronics was 4 semesters of circuits 1, circuits 2, electronics 1, electronics 2, or or DSP with signals and systems 1, signals and systems 2 in a DSP class. And it's like, I could tell them to go buy Oppenheim and Schaefer, and that's usually what I do, but there's probably a better way for someone who wants to learn specifically analog electronics and DSP for electronics for audio. Does anyone have any ideas?
Man, it feels like a dying art almost in a way, like fewer and fewer of our students coming in from undergrad, like know circuits, like, so they learn it like on the fly, but it's, I'm worried about it actually, like disappearing a little bit. Like
I know
people,
pretty good.
people are doing such like high level stuff these days that they don't like engage with, what's an inductor or something like that,
Yeah,
So,
well, I mean, barely anyone even makes inductors anymore, right?
yeah, sure. You don't really, I guess, need to know what they are, but it's so useful to understand them just for doing, any kind of like programming or DSP, So.
I heard an interesting comment at AAS. It was I think the guy from Studio Devil said, anyone who actually really understands a transformer died 50 years ago.
I guess. I actually have a recommendation. I have a very good source of knowledge for music electronics. Actually, the way I learned the second time, because I did EE for my undergrad, but I feel like I really learned electronics much later during my master's when I worked on the Moog filter with Stefan. I found a series of lectures from a professor who is, I think, is it Georgia Tech? Aaron Lanterman. I'm sure some of you have heard of him.
Yeah, that's Georgia Tech.
Georgia Tech, right? He's Aaron Lanterman. He has a YouTube channel. I think he just changed his name on YouTube to Lantertronics, I believe. He used to be Above Nyquist, which is an alias. It's great, very funny. But he just changed it. I follow him on Twitter as well, and he just announced a new name for his channel. His Lantertronics. I don't know. Maybe we can post this somewhere. I can probably type this on the Facebook group, Facebook feed. But if you browse his YouTube channel and then maybe some forums, you can find links to his lectures, and they're very, very good. He covers RC filters to begin with from a very good point of view, very useful for music DSP. Then he moves on to distortion circuits. He does a bit of filter modeling, like DSP stuff. It's a very complete course. He's been running it for, I would say, 15 years now. Wow. And it's very good. I can type that. Aaron Lanterman, he's my go-to.
Yeah, that sounds perfect.
Yeah.
I'm sure not the only one. I'm sure Kurt likes his lectures too, right?
Oh, they're nice.
Very good stuff.
There's another one along those lines as well, and that's Electronotes, if you can get hold of them.
Electronotes.
Yeah, that's the classic.
That's good. I mean, Aaron Lanterman bases a lot of the lectures on Electronotes, so you should check both.
It's good resources. I'm seeing a lot of comments from people that I feel bad that I didn't think to invite to this day. I see Marco. I see Sean Costello. I see. Maybe we'll do a round two.
I guess.
Get you guys on here. So, yeah. Let's see what else we got over here.
Was the person who was asking that question, Russ, were they asking about specifically like virtual analog stuff, or were they just wondering about how to like transition from the MATLAB stuff to the like C programming of things, or the C++ programming?
I think they just, most people have only come out of school and done MATLAB. I mean,
yeah.
I'd say step one is ditch MATLAB and learn Python, right?
True.
Hey,
Yeah.
can I actually ask about that? Like, is that the way things are going in industry, basically? Like, is MATLAB disappearing completely?
Yeah, we mostly use Python, right?
Right.
Is there everyone?
Yeah,
I still use
100%
Octave.
Python now.
Huh. Okay.
MATLAB costs for the non-university, it's like, I don't know, maybe I'm not supposed to say this, but it costs like $5,000 a seat. So if you're in audio, like, no.
Octave, if you like MATLAB, Octave actually got pretty good. It used to be useless, but
yeah, that's true.
It's pretty nice now. I mean,
I have a bunch of old MATLAB code that I'm slowly porting to Python. I mean, it's mostly old ideas I fleshed out and then never turned into anything, and I kind of don't want to lose that, but I guess Octave might work with that.
What do you guys hate most about MATLAB?
The price.
Yeah, the price, and honestly, I feel burned by the fact that I wrote a bunch of code that I can no longer even run because I don't have a license. So there's a couple different, there's whenever a new programming language comes out now, I'm looking to make sure that it's actually truly open source and that it's not going to be owned by someone that I'm going to have to pay a license fee in order to run my own code in the future.
I was just gonna say indexing from 1 and not 0.
Oh,
That's my biggest too. The on the
sucks too.
Python like MATLAB thing, the flip side of that is like a couple years ago I tried to transition to Python for scientific computing, and I felt like it was such a pain in the butt to maintain a working installation.
Yeah,
with all
that's
kinds
true.
of dependencies. And the thing I like about MATLAB is it kind of just works.
You should check out Jupyter. Are you using Jupyter at all?
No, I'm not.
Yeah, Python is a little hinky to get into, but if you use Jupyter, I'm using Jupyter Lab specifically as like an IDE, so it's more of a MATLAB-like environment.
I like PyCharm for that.
PyCharm's really good too. But the nice thing about Jupyter is it has Jupyter notebooks and it has Jupyter Lab and it has all of that, and it sort of solves the environment for you. And then there's Python itself has like newer environment stuff in it too, but even a couple years ago, it was a lot harder to sort of get up and running with that stuff. But now it's really easy if you just.
I think we're getting hot here. The questions are rolling in. We're trending. Valhalla, Sean asks, what books do we recommend for people interested in this field? And then also, what Python DSP libraries do we use?
I'm going to recommend Stefan's book.
Yeah.
Yeah, okay. There's no virtual analog in there, though. I mean, so you're going to need to go to Kurt's
It's the same. It's the same stuff.
It's transferable, Stefan.
It teaches you how to solve differential equations, which is very helpful.
You'd think actually, but man, virtual analog is still. I feel like a newbie with that stuff. Like I've done a bit with you guys, but it's a whole world. That has its own rules. Feels like.
I'll go ahead and say virtual analog is not all of audio DSP either.
No.
Right,
that's true. At the moment, but.
I mean, yeah.
Where do you learn how to make a reverb from?
I have to recommend I have to rep Miami and go with Will Perkle's book.
Yeah.
It's very practical. It's how to build effects in C++. He goes through all the theory. He has his own signal processing library that you can use for free to build this stuff. It's very practical. Like, how do I build a useful thing oriented?
Yeah, one of Will's students has a really good master's thesis that reviews all the feedback delay network stuff, right? I can't remember the name. Yasmin or something. Yeah, Yasmin Fournette.
Yeah, I think I know this.
It's like a master's thesis, but it's really good.
Nice.
I bet you could make yourself a pretty good reverb if you had enough delay pedals and a big enough mixing board.
You need to get one of those matrix mixers, but yeah.
Yeah.
Yep.
That's what Tony Agnello from Eventide, when he did the 2016, that's how he told me that he prototyped it. Was Eventide made that 1745 delay line, which was just a digital delay line. He took a big recording console and bust out to delay lines and into them and into channels and sort of set up all the matrix mixing stuff that way to test everything out the first time back in the 70s.
I feel like that's the classic answer though when somebody asks how to make a reverb, right? It's you've got to suffer. You have to go through, pay your dues, just listen to a lot of stuff, and then maybe you'll be able to do it. Yeah. There's no book that tells you how to do it, which
it really isn't.
It's unfortunate.
I mean, I've done a lot of it, and I still don't think I know how to do it, to be honest. I know some ways that worked, but I don't feel like I can truly extrapolate from those ways.
I only learned how to make a reverb because I talked my way into a job where people had already made a bunch of reverbs.
Yeah, but I guess what I'm saying, same thing. I learned a lot of how I know how to make reverbs from the existing Eventide reverbs, and then from other reverbs I've read about. But I would say 3 out of 4 of the new reverb structures I try out myself sound terrible. And that's not the case with other DSP algorithms.
I think it's hard to visualize. It's hard to map a sound back down to reverbs are they're pretty simple mathematically usually, but they're just large amounts of delays and additions and stuff, right? It's kind of hard to imagine what it's going to sound like.
Do you guys feel like there's still a lot to do in terms of reverb design? Or is that problem kind of closing up, or is there more?
I think there's a lot to be done on reverb.
I mean, there's the whole
what's the challenge for you guys? Is it not the case that there's something on the shelf you can use, or or it doesn't sound good enough, or is it about speed or something, or you know, or like how fast it executes, that kind of thing, or is it like, what are you looking for in a new reverb design these days? I'm curious because
I think in reverb, there's like this vast chasm between like full on modeling the PDEs with heat advection and crazy stuff like, you know, Brian style, and then just all pass filters and, you know.
You mean Brian Hamilton?
like suppose
Brian
like
Hamilton, yeah.
Yeah, okay.
Like there's a whole middle ground between like numerically simulating it, the exact physics of a room, and then just having a bunch of delay lines kind of that sounds like a reverb. There's everything in between is kind of unexplored.
I think it's difficult too, because from a market perspective, it's not clear to me that there's a lot of reverbs out there that all sound good and different, but it's not clear that if you just came out with a new one that also sounded good and different, that there would be a market for it, just because there's so many. So I think from a DSP philosophical standpoint, I agree with you, Kurt, that there's a lot of interesting stuff there, but I think from like a plugin development standpoint, I'm not sure that there is, but maybe I'm wrong.
I think it's a bit like reverbs are like a commodity now almost. Like everybody has one if they want one. So you've got to put some kind of twist on it that makes it like somehow more creative or more interesting or easier to get good results quickly. I think that's the stuff that we're thinking about, at least.
Yeah.
It's not about realism at all. Like that couldn't be further from
because you can always use an FIR, like a
Convolution,
convolution reverb, if you want realism.
Except I remember that one conference where Barry Blesser was just ragging on convolution reverbs. Do you remember that at WASPA? Like he was just like tearing us all down for doing it. Oh, sorry, that's my kid.
What were the reasons?
He's mad about reverbs too.
What were the reasons for tearing down the convolution reverbs? Just because you can't it's just like you can't really do much with them. They're not that creative.
He has a book called Spaces, I think Spaces Speak or something about how it's just not exact. It's not, we sell convolution reverb like it's the gospel truth of that sound in that moment. And he says it's not true at all. Even among, go ahead.
His thing is that air currents and heat variation kind of are constantly interacting with the speed of sound propagation. So at least that's how I understood it.
Yeah, that's kind of how I understood it too. Is that it isn't true physics.
Yeah, I could see that. I mean, you're really only capturing like that specific moment in time. How does this room sound like at this exact moment that I recorded this impulse response kind of thing, right? That's his thing.
And he's saying it's not even that. It's not actually true to the moment. The closer thing would be like the stuff that you do, Stefan, like the finite difference scheme stuff.
Yeah. I mean, it's tricky though, because it's overkill for us. Like in order to get that sound, like we're doing all this redundant stuff. It's just that we don't know what to remove, like without killing the sound, So it's really hard. So.
So to accurately model a concert hall, like for real, how many like big stacks of GPU are you using?
It's not as big as you'd think, but it all comes down to the like you got to have centimeter resolution for the acoustic field. So if you imagine like a concert hall full of Lego or something, right? Like that's each bit of Lego is going to be one number you're going to have to look after. So it's like 1 million per cubic meter. And it goes up from there, right? So you're into the, just like, I don't know, gigs, like just to hold on to the acoustic field. So it's huge. And there's no way we can hear all that stuff. Like we just don't know how to simplify it, So.
I mean, so that could be an avenue.
Yeah, you get it all though. That's the cool thing. You can get it, but then like, it's not clear like what to remove. Yeah. So.
I mean, some of the demonstrations you guys have played really do sound amazing, but I know it took like days to render them, right? Just a short section.
It's not days anymore. Like Brian's system, I think like it's down to sort of hours now for an impulse response, which is okay, but it's hours. It's not real time. So And that's on a set of GPUs. So like you got to have your own hardware for that. But it's coming down. Like I'm figuring, like by the time I retire, like maybe something will happen.
Well, all our algorithmic reverbs and artfully designed, painfully designed in our cave reverbs will be replaced with finite difference scheme things.
Well, I don't know. I mean, it's sometimes it's hard to compete with a really good FDN, right? Like, and that's what kind of gets me interested in this, is like trying to figure out like how to make an FDN sound like a real room, like, or how big does it need to be in order to capture that? Can we bound that or something, or I don't know.
What's the name of someone asked, what's the name of your book?
Mine? Oh, it's called Numerical Sound Synthesis, Numerical Sound Synthesis. It's 10 years old now, so it's
still relevant.
Is it still true?
Man, I keep finding new people. All sorts of people write me with like, with snarky comments about things that are wrong in there. Yeah, so they'll get fixed. So
hey, at least
they're not
people
getting
are
free
reading
copies.
it, right?
I don't know. Maybe. Yeah. Let's see.
Here's a doozy of a question. I don't know. Let's see. Would it be possible to create a sound field with high frequencies just above the range of hearing with perpendicular waves and a bunch of ultrasonic speakers?
Yeah, probably.
I don't know.
Yes.
I mean, don't people do that for modeling room acoustics, or they used to?
Like
they
50
build like
on each
scale
side.
models.
Yeah, right. The scale model stuff.
Oh, with the gas, right?
Yeah.
That's right. Yeah. Huh.
Yeah, but
Crazy
the goal
stuff.
is to create the effect of being able to listen and dance into an interactive three-dimensional fractal.
Oh my god!
I think this is, you want to start a PhD thesis, right?
Yeah,
here.
I think you need to go to. I think the
You need to find an advisor who will sign off on that. And
yeah, you have reached the limit of our knowledge here. That's the answer to the question. I haven't heard a lot from you, Dave. I feel like you have the most do-goodery work of all of us. Like
making toys.
We're like making toys, and you're
Yeah.
trying to like make the world a better place. I mean,
only for the past 5 months or so.
Okay.
Before then, I was just playing around making funny sounds. So
bacon sounds, right?
Yeah, that was it. Bacon.
I remember that.
Yeah.
Sizzling
Really?
bacon.
Bacon.
Sizzling bacon? You synthesize sizzling bacon?
Yeah, no, it was sizzling bacon is meant to be replaceable for the sound of rain.
oh,
Digital Foley stuff.
Nice. You did a lot with adaptive mixing and stuff too, didn't you?
Yeah, and that's what I'm kind of trying to bring into the project I'm working on at the moment. So the idea is we're adaptive mixing for people with dementia. Try and work out when people are uncomfortable with the radio music they're listening to, and then it's kind of radio personalization. So you kind of when someone's a bit uncomfortable, you mix in into their own personalized playlist created by a music therapist, and then when they're sort of more comfortable and happy with the environment, you can then mix back to whatever's on the radio, just to sort of cut into all the radio broadcasts of people, dying from COVID and everything else.
Yeah. So that kind of comes into the, we haven't even talked about, two of you guys, your titles, like you, Fabian and Julian, you're not just DSP anymore. It's like DSP/ML.
Yeah.
That's true. Yeah.
Oh, right.
It sounds like I feel like
top secret right now.
Is it top secret? Yeah. I mean, so machine learning and DSP, I feel like I'm sort of the good old fashioned American get her done DSP engineer, and everyone's starting to put machine learning in their title. And I'm like, crap, I guess I got to go learn a new trick. What techniques in machine learning are you guys using? I guess the buzzwords is the deep learning, right? Maybe Dave, if you're at liberty to talk about some of these things, maybe you could explain.
Yeah, quite a lot of the stuff that I'm working on is almost exclusively deep learning now. Though it wasn't deep learning, and all the feedback I got from that was, but you're not using state-of-the-art techniques, so all your results are not relevant. doesn't matter that I'm getting 98% accuracy on most metrics. I can find it's just not good enough because you're not using deep learning.
Wow.
But that's because sometimes I kind of like the more traditional methods as well, because deep learning is good to a point, but it's only good when you've got large amounts of data, in my personal opinion. If you don't have enough data, then some other techniques can often be a lot more powerful. At which point it kind of depends on what you're trying to do and what you're trying to achieve. If it's something that you can model, you can simulate, then you can definitely just keep on throwing audio at it, automate some system, and then sample something at hundreds of millions of times, and that's not too much of an issue. If you're working with some of the automated mixing stuff that I've done previously, where you're trying to get, you're lucky if you can find 5 different engineers that can mix the same set of stems to produce an output. It's like, well, I can't get 10,000 different mixes of this track from 10,000 different engineers. That's just never going to happen. And they're certainly not all going to be a good quality if I do, because they're inevitably all going to be whoever I can convince to do it, or whatever else. So at that point, I think it's the lack of data where you need to start becoming a bit more clever with things. That being said, like, deep learning is incredibly powerful and is incredibly useful, and some of the results you can get from that stuff blows my mind, and I'm working with it day in, day out. I think some of the interesting things at the moment, I don't know what Julian and Fabian, who are probably the other 2 ML guys, are. Some of the stuff I'm really looking into at the moment is a lot more of the transfer learning, which is where you learn on one particular topic area, sort of get a general idea, and then try and transfer it over to your specific domain. And the general impression I get is that's going to be quite powerful.
Sorry, I was interrupting you there, Dave.
No, I was not.
I was going to say, I think what's super interesting at the moment for, I guess, me and Fabian and the stuff that we're doing is that there's this kind of like weird gray area somehow in between machine learning and DSP, where like machine learning people come up with certain kinds of methods. Like DSP people haven't mostly gotten into machine learning properly yet. So there's all this stuff, all these kind of overlaps, where there's lots of interesting new things to try and interesting things to discover. Because the actual kind of building blocks that you're working with are almost identical. I don't know, there's a line we were talking about in an unpublished paper the other day for next year's DAFX, actually. They kind of summed it up for us, which is like if you look at convolutional neural networks, I mean, they're obviously like nonlinear FIR filters, right?
Yeah. Obviously, everyone out there agrees, probably, obviously, yes.
If you look at the structure, it's super clear, right?
Yeah.
Yeah.
And recurrent neural networks are like special kinds of nonlinear IIR filters.
Sure. Yeah, because there's feedback.
Yeah, exactly.
Yeah.
So I think these things, which are often from the machine learning perspective, kind of treated as like almost unknowable black boxes.
Yeah.
Like if you understand the DSP, then you can actually pretty easily understand what they're doing. And that's quite a fertile ground, I think. Like there's some new insights and cool things that you can do that come from that.
This kind of ties into another question from, from Valhalla. He's asking all the questions, by the way. I think maybe he's the only one watching.
We should invite him next time.
Yeah, I think he's a guest for the next one for sure. Do you think we can invent sounds that have never been heard before? Which I would think that machine learning comes into this possibly, for sure. And will people buy sounds that have never been heard before? It's really the bigger question, isn't it?
I was going to say you could definitely create sounds that have never been heard before. Whether you want to hear them is a different question.
Yeah, they're used for like horror movies or something.
Yeah, well, I mean, I guess the real question is, it's a perceptual question, right? Like at what point does the difference between 2 sounds mean that you have heard it before or not heard it before? Like obviously white noise is always different, or can always be different for the most part, but it all sounds the same.
Yeah, I think that's totally right.
given the same sound, right, which is just an impression on our brains, like, are we even hearing, the same thing? Like, are we having the same experience? Like when we both hear the same physical.
And sometimes when I hear the same sound, years apart, I'm sure I have a different experience.
Yeah. We lose hearing. We're transient beings. The rooms change. Everything. It's
I have different hormones coursing through my body, or less and less as the years go on.
It gets philosophical really fast, doesn't it?
I think, though, generally, I'll plug myself a little bit. A lot of what I'm trying to do with Newfangled Audio is just do things that other people aren't doing, because I think analog modeling stuff is actually super interesting, and that's what I did in my master's work too. But it seems like everyone's doing it, and I get frustrated because I feel like to some extent we've got almost 20 years of DSP research where we haven't really progressed past recreating things that existed, 50 years ago or 30 years ago or whatever.
Absolutely.
And I think it's a useful and good thing to do. And I think it's interesting. One of my college roommates from my undergraduate was an electrical engineer, and he went on to be a analog electrical engineer. He designs op amps for analog devices and like linear technologies and stuff. And we think about the math behind nonlinear analog electronics way more than he thinks about the math behind nonlinear electronics. Like, we know more in analog modeling. We're solving the nonlinear ODEs. They're not solving the. They're thinking at this voltage the transistor turns on and then it's forward conducting or it's reverse biased or whatever, the way we learned it in electrical engineering school. So it's interesting and good to do that, but I just personally felt frustrated that someone needs to make the new sounds to kind of push where we're going forward. So that's what I've been trying to focus on, and other people are doing that too. I don't want to claim to be the only person that's doing that, but that's where my interest lies nowadays, and I think there's a lot of fertile ground there.
It's another question from YouTube. This is going to bring it back out of the deep end. And I guess we're going to wrap up soon too. And I'll wait for Dave to get back from the restroom or wherever. So I'll just like hang up on him, See ya.
Great.
What would you guys recommend as an overall best plugin? I haven't owned one yet. So this is a plug-in virgin. What should this person buy?
Oh, don't do it, man. Don't do it.
Do it.
I recommend A-Gain from the VST 2.4 SDK.
Yes, that one's solid.
A-Gain, it's a good one.
Yeah.
Oh wait, that's the demo one, right?
Yeah, it's just a gain.
Okay, yeah.
Gain slider.
Right, yeah.
Well, since Sean has been so great, asking so many great questions, I recommend a Valhalla plugin.
There you go.
So yeah, get a shimmer or get yourself a good reverb. Get a shimmer,
Good
get
choice,
the room.
yeah.
Yeah, they're well priced. They sound good. And naturally, I recommend Eventide stuff, but whatever. And native stuff.
You just saved his job.
iZotope stuff. Yeah, that's right. The cool thing about this is we talk at least once a year, and people use all of the stuff we make together and make new sounds. I think one way to make new sounds is just combine different companies' technology, right?
Yeah, I'll say I've been in this business since I graduated college, so it's like, I don't want to think about it, 18 years or something like that. And it's a fun business to work in because of the topic, but it's even better because of the people. Almost everyone I've met at any company has been great to hang out with. So
It's a fun community, yeah.
it is.
Yeah. And a lot
I think
of
that it might be competitive, but it's so not competitive. Like, it couldn't be further from competitive.
Yeah. I think it's everyone who's doing this wants to do it, right? Like, or is really interested in it, because otherwise we just go work on something that pays well. But it's So you get good people.
Finance DSP.
Yeah.
Finance. I mean, it's the same math, right? I think
We should have invited Aaron.
we should have. I was gonna mention his paper from the 2014 DAFX because to that, talk about virtual analog modeling and filters, that his paper actually brought it all home for me. The whole like VA design thing. It's real simple, but it's just, at least for an electrical engineer like me, I was like, oh, I get it now. Thank you for writing it that way. So
It's a good
maybe
paper.
we'll invite
it's a
Aaron
good
next
one.
time. Yeah.
Hey, just before we go, like, is DAFX, is it still running actually this year or what? They haven't shut it yet, right? Or
I don't know.
I don't know if we can't say officially, right?
No, I don't think we
Probably
can
not
say
our place.
officially. Yeah.
We don't know officially.
no, but there's no word, right? Or okay.
There's no official word. I would assume that the papers are still being published no matter what. That's my assumption.
Yeah, right.
Right.
But it's not going to be a virtual conference. We don't know.
I actually don't know. I don't know if it is or not.
Let's just wait because we
Okay.
really don't know.
It sounds like you do.
But I don't. Did anyone submit a paper here?
2.
I didn't actually this year.
No, I didn't submit any this year.
I think we were all, I was thinking about it, and then when coronavirus started happening, I was like, oh crap.
That's what happened.
Changed a lot of my plans.
Dan and I were talking about doing one, and we just didn't. I kind of dropped the ball after all this stuff. So
We
Did you
got
guys-
one in, yeah.
Did you guys plan like just lives change much because of this whole thing? Like, I mean, obviously everyone's not going outside, but I mean, were you guys planning on writing papers and you decided not to, or you're not thinking about it this year?
Yeah, kind of. I mean, I was going to do a DAFX, but then I figured I'll just wait for Copenhagen, or something. I don't know. So, because I mean, it's not just about writing the paper. You want to go and see everybody, obviously,
Yeah.
right? So, I mean,
We wrote one, but I guess we weren't quite as stressed about it as normal, maybe.
We're not first authors either, to be fair.
I mean, there's been years when like you guys have had like 4 papers, or like Kurt, you were like had like 5 in 1 year or something. Right?
Kurt had a session one year. I remember.
Don't talk to me about Trondheim.
I'm
The
lucky to
danger
get
of
one.
overachieving.
More like self-destructive grad student mode.
That was keynote plus session, right?
that's
Yeah,
right.
well, I mean, I wasn't invited to give the keynote. Julius wasn't able to go, so that's how
I know,
that's how it got handed to me.
I know.
I guess that's the other unmentioned sort of like thing, that if you want to get into DSP, you should basically read all of Julius's online.
Yeah.
books.
Yeah,
Like grandfather, godfather, or whatever of audio signal processing.
Yeah,
It's-
the whole book, the online book is amazing.
Yeah.
I use
That
that.
book- yeah. The DAFX book is great too, I think.
DAFX
I
book
learned a
is
lot
great.
from
Yeah,
it,
second edition. I guess there's 2 editions now, right? Yeah.
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 Yeah, that
Second edition.
really helped me when I was like getting into this at the first. I bought it at like an AAS conference when I was like just starting out, the first edition. And then the papers too, which are all free online. I reference those still a lot.
Hey, we're like working on Udo to do a 3rd edition, actually. Like, do you
Really?
guys- is that one like, is it out of date now? Do you think? Because it's 2011, right? Isn't it?
Yeah.
Yeah.
It's probably, it's still very useful, but there are a lot of things that have happened since then, right?
Yeah.
It would benefit from an update.
Yeah.
Yeah.
You should do it.
No, Udo's doing this one, man.
I mean, he should do it, yeah.
Yeah.
That's what I said. Yeah, that's what I said.
No.
Oh, imagine if we'd had Udo in this chat.
I'm sure I'll have the blessing to do more. Maybe Woody, you want to lead one, or
Yeah, I could at some point if we're doing multiple rounds.
yeah, we'll hear from the El Jefe when this is done, whether or not we should redo it, right?
I think you
How many
should.
people ended up watching?
Yeah. Cool. I don't want to take, thank you guys so much for doing this and getting on. I know it's late for some of you. We'll wrap up. We've been on for about a little over an hour. So any sign off comments so we can go through one by one?
It's really good to see you guys actually. Like I haven't seen you guys since last year. So
yeah.
Nice to see you. Glad to see you're safe.
Good to see everyone. Yeah, normally we have record producers and like mixing engineers who all have their own kind of their own full social media stream of all their stuff and that's not really the situation here, is it?
They have
names into Google Scholar.
Google Scholar, yeah.
ResearchGate.
Yeah, ResearchGate, yeah. You can find Julian on Google Scholar. You can find.
If you type in somebody's name in Google plus DAFX,
yeah,
you get some stuff.
Yeah, for sure.
That's the way to do it.
Or buy Stefan's book. Yeah.
Buy Stefan's book. Yeah.
Yeah. Hey, there's a DAFX opening actually in 2022. Like, do you guys want to do one in New York or something? That'd be cool, man.
If we could get a university, NYU could probably host it. Maybe that would be pretty cool. Yeah, it's usually in Europe, right?
It's always been in Europe except in Canada once.
Yeah.
Does it even need a university? I don't know.
Well, we couldn't fit everybody in Eventide's little mini New Jersey warehouse. That's for sure.
You guys don't want to come to New Jersey.
I do it, man. I don't care. Fly to Newark.
Yeah.
Miami, Will Perkle might want to do it.
That would be cool.
Miami would be cool.
Miami would be dope. That's a nice campus.
Yeah.
I want to go back.
I would go to Karma too.
Yeah.
That's never gonna happen.
No.
No? Okay.
No, it's not.
They did that Linux audio conference at Karma, right? They put on one conference at some point.
Yeah.
I don't get it. When you go to a conference at Karma, where do you stay? Not Palo Alto, right? Or
you pay $300 a night to stay at a half bedroom motel off.
See, that's the problem.
Yeah, $500 to be in someone's garage or something.
Yeah, to Miami.
Yeah, Miami sounds really good, actually.
Miami would be nice.
I mean, there was a Berlin DAFX in the cards, right?
Yeah,
so
right.
We haven't heard. I mean, it wasn't up to us.
Who was it up to?
We were in touch with what's his name, Henrik from TU Berlin, but I haven't talked to him.
Oh, yeah, that's right. Okay.
I don't know how that developed. This was all depending on some funding and research projects going on, but we should check in on that actually.
Yeah, definitely.
So I got the official Tony, Big Boss says, do it again and talk more about matrix inversions. So thank you guys.
Oh, great. We're going to do a book club.
Yeah. Yeah, I mean, we can have Fabian back and give a whole lecture on bookless stuff, right?
Yes.
Julian has a booklet paper as well. We
he does? That's right. That's right.
Yeah, we can both do a booklet session.
Yeah.
Booklet search.
There's tons of modeled bookless stuff in blocks or Reactor, right?
Yeah, a little bit.
Yeah.
A little bit.
Yeah, we can have circuit modeling sessions here or something. I don't know.
Yeah, I guess we could do themed things, right? We could ask
you really could. You could have an FDN session or something.
Yeah,
that would be cool.
Yeah, that would be interesting. Yeah.
We can have an 80s rock session.
Yes. Nice.
Yeah.
People want to see. Nice.
Some themes.
To buy that, do you specifically have to Google Devo hat? Or is it just is it some generic household hat?
There's no other use for this other than Devo Halloween costume. Yeah. That's the only application of this product.
Eat soup out of it. You know, I mean,
that or an awful lot of ramen.
awful lot.
Yeah, we shouldn't drink when we do this talk.
That was the point, right? I think,
Yeah.
The only problem with it is I have to pee really bad right now.
Well, that sounds like your sign off then, right?
I think so. I think so.
Gotta use the bathroom really badly. I'll see you all later.
Yeah. So thank you guys so much. And hopefully we see each other this year, if not next year.
Yeah.
Okay.
Stay safe.
Stay safe,
Okay.
everyone.
Stay safe. Thank you
Good to
very
see
much.
you all.
Thanks, everyone. Take care.
All right, see you guys.
Bye.